Hey everybody, this is Larry, this is me going over here. This is Larry, this is me going over Q4 of the weekly contest for 11 count substrings that satisfy K-Constraints too. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So this one, it's a hard problem. I didn't solve this during the contest. I had all the pieces together, but I just didn't get the last bit across the finishing line, which makes me kind of sad, to be honest. You could watch the live portion, and it still took me a while because, I don't know, this is just, some days you're good, some days you're not good, and today, not so good. but yeah, so okay. So this part is very tricky for sure, but this contest is, this problem in general is pretty tricky for sure, and yeah. Sorry, I'm stalling a little bit because I'm trying to bring up the drawing pad. So yeah, so this idea is for this problem, the first thing I visualize is kind of by drawing segments, right? Okay, so I trust that everyone kind of looked at Q1 and kind of think about this. Okay, actually, let me step back for a second because I think sometimes I jumped ahead too much and people complain about it. So that is, which is true, and it is my apologies, right? So okay, so the first thing that I want to set up is that the first thing I want to set up is okay. Let's ignore the queries for a second, and we want to go from 0 to n. We want to get every possible thing. Then now, one of the things that I want to set up is just a prefix sum. And there are a number of ways you can write this, but the idea is just to allow us to do a substring query in all of one time, where we can count the number of zeros, count the number of ones, and, well, as a result, just check this K-constraint thing, right? This part, honestly, I'm not going to go over too deeply. It is prefix sum. I'm not going to go over it too deeply because this is already going to be a long video. A lot of it is the live portion, but even the explanation only part is going to be a little bit long, so I don't want to dwell too much on it. You definitely need to know this as a prerequisite. There are a lot of problems on Leetcode with prefix sum, so you should know about this one, right? So I'm not going to go over in detail, and I kind of wrote it here as a reference, right? So okay, so let's say we have the prefix sum, right? So now, and what does this prefix sum mean for us, right? It means that we're able to do one query like this, so with prefix sum, we can get ranged. We can we could get range queries. Count for zeros and ones, right? So that means that for any range, then we get the counts from 0 and 1s. Now, there are two ways to. So another thing that we want to pre-process is how far. This is I talk about this a lot in different problems, but it's about this idea of contribution, right? There are two ways to do it generally: sliding windows or binary search. I did it with the binary search. You could do it with sliding windows. I think it doesn't matter for this one too much. We can upsolve it later, but this video is already long, so maybe not to convert it from binary search to sliding window. But the idea behind binary search is just that the longer string you have, it's going to be more. It does not satisfy the K-constraint, and then as you shorten the string, you're more likely to satisfy it. And then there's some transition, and then you can just binary search over it, right? Again, this problem is already hard enough, so I'm not going to go over the binary search and why you can binary search over prefix sum to get the answer. You can, I would say though, with these two ideas, if you want to practice not on Q4, you could actually use this as practice to Q1. I know that the constraints are 50, like n is equal to 50, but still you could practice your code on, before you continue with the rest of this video. If you do not have a strong grasp of what I'm talking about with prefix sum and binary search, practice it on Q1, right? You have to do your homework to learn, right? understanding is not good enough. You want to be able to solve these things, right? In the future, you don't want to just understand them. You know, if there's an interview and they're not asking you, hey, here's a thing, do you understand it? No, they go, hey, here's a thing, solve it. So practice solving it. I know I'm being a little bit naggy, like you know, like yes, Dad, thanks. But yeah, and so come back when you have a grasp of binary this. Of course, you can also do it with sliding window. So the idea here is that for each index, we want to pre-process the input array to figure out how far to extend it, right? And what I mean by how far to extend it means that, okay, this is where the drawing comes in. Right, I'm trying to copy the input a little bit. Hang on. Okay, this is a stupid input. So let me try, just write a random input, right? Don't know why this is blue, but whatever. Okay, so then let's say you have k is equal to 2, right? Then now here, we're trying to figure out, let me change the color real quick. For each index, we're trying to figure out how far we can extend. So for the first index, it goes all the way to here. What is the, or rather, I guess it depends on how you want to count it, but I mean, it goes all the way to here in the good writer thing, meaning that if we extended one more character, we do something like this, this is no longer a writer string, right? And what does this extension mean? This extension means that there are four numbers, but also that means that there are 4 numbers beginning with 0 that has a solution, right? Meaning that this is one number, this is one number, this is one number, and this is one number, and all of them individually satisfy satisfies the k equals to 2 constraint, right? Okay, and then now we do it again for the second string or second character, right? So maybe I'll okay, I'll change up the color real quick. And then now it goes all the way up to here, right? So that means that there are 3 possibilities, right? Because now adding the extra 1 will give you 3 ones, which is, oh, actually, no, I'm wrong. I forgot. I confused the n and the thing again. So okay, for k equals to 2, actually you keep on going until you have 3 of each. So that means that for k is equal to 2, sorry, my apologies. I mean, the logic is still the same. It's just that, you know, you extend it a little bit more. And in this case, you go all the way to here because you have 0, or you have 2 zeros, right? And from the third index, you have, let's see, actually, I guess the same thing here. And then now here you go all the way to the end. This goes, and then probably everything just goes all the way to the end if you can go all the way to the end, right? Okay, and of course here, as I said, each of these segments represents other strings as well, right? For example, with the first index, you have 5 things. Don't know how. So that represents 1. Let me change the colors. Actually, it represents 1, 2, 3, 4, 5 strings. Okay. So that's basically the idea, right? So then now, how can we think about this? Okay. So with this, you're actually able to answer Q1. So definitely, like I said, practice this idea and yeah, answer it. So then now for Q4, for this, the one that we're solving, we're trying to basically have a query, right? So then now it becomes a little bit more, you know, now it's a little bit, hopefully more clear. Yeah, I'll talk about how I did it in the past. But yeah, basically each query will look like this, right? Like a chop, maybe a straighter chop of like something like this, right? And then you're trying to count the number of strings inside it, right? So there are 2 things to notice. One is that this, because looking at the first index again, as we say, the string here are going to be do, right? So there are 5 of these, but they all start at 0, which is outside this range, right? Just to be clear, the black lines are the range that we're talking about. So we want this to be the left, this one to be the right, and we want to kind of keep track of this, right? So that means that if you look at the first index, everything that, so we don't care about this line, right? We don't care about the one line here either, right? I'm erasing it just because it's getting a little bit messy, but you get the idea. So then now, what lines do we care about? The lines that we start inside the middle, right? So then now, yeah, so this line we care about, which is length 5. This line we care about, but it's too long. We'll talk about this later. This line we care about as well, right? I guess this, I was too aggressive on drawing. We don't care about that one. So, okay. So we care about these, right? So then now, so two things. One is that, okay, erasing the circles for a second. And okay, replacing them with arrows. So then we care about these ones. So then now the first thing that you can do is by summing over the stuff that's inside, right? Yeah. So for every starting index, so let's say this is L and this is R. I actually use start and end, but whatever. L and R, right? So that means that for everything that's inside and inside of that starts with L, but also ends before R, we can just sum, right? And this we can do a prefix sum on. Prefix sum on a prefix sum. We'll talk about this in a sec, but keeping in mind that, yeah. So one thing to notice is that as we move this index from here left to right, the right side of this, and this is also more obvious if you do a sliding window, is that as part of the sliding window, the right side of the window only keeps going to the right, right? So that means that in a way, if you just look at the right side of these, I mean, I drew this a little bit poorly, but it goes from here to here to here to here to here to here to here, right? If you look at only the right endpoint, it is monotonically increasing, right? So what that also means that there is a point in which there's an index in which everything before this index, the right endpoint is before our query, and so then here we can just do a prefix sum, right? So then now we know the length of this. We can just do the prefix sum all over the thing. We'll go over it in code, but on the stuff that's to the right, and this is the thing that I struggle with basically my entire contest, and I just couldn't. I didn't think of it this way, honestly, but like I missed this visualization because I was trying to figure out how to, like, okay, now we have all these sums, how to subtract out the extra stuff. But it turns out what you want is not to subtract the extra stuff. It's just because I was, this is getting a little bit messy. So let's clean this up a little bit, right? So then now, let me redraw this for a second, right? Now we have these segments that are basically how I visualize this. And actually, during the contest, I drew it out on my notebook. But yeah, so you have all these segments, right? And as we said, the right endpoints are going to be always increasing or the same, so monotonically, whatever, right? And then here we have some query, right? That, yeah, it's fine. Okay. I just say we have this and here, right? And the way that I was thinking about the entire contest was that I was trying to sum up, so we don't have to care about these two. So these two we don't care about on top. We don't care about because they start before, right? Here we care about this one. And so during the contest, I was trying, you could do the math on this to figure out how many strings are on it. That's fine, right? Like we'll talk about it more in detail. But I was trying to figure out all this and then just chop off the ends and basically my entire problem was just try to figure out how to chop off the ends. But it turns out that the right way to do it is actually, instead of chopping off the ends, you just sum up all the stuff that's inside it in the middle, like perfectly inside. And then here, so what is the thing here, right? Well, we know that everything after, and also just to add a few more lines, because yeah, a few more lines because it has to be, you know, here, because the key thing to know is that in these next in the adjacent segments, everything is off by 1, right? Because if you think about it, the starting endpoint, this is 0, this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8. And that's, we did it this way intentionally to calculate the right endpoints of these things, right? So then now, that means that here, on the right side, what happens, right? That means that whatever this is, let's, okay, yellow is impossible to read, sorry. So let's say this is some L, and L in this case, because you know that it starts at, you know, let's say this is 4, mapping to this 4, then now L is, so then you have the, how do I say it? Sorry, give me a second. So then for this one, we know what the value, we know that this length goes to R, right? So then that means that it is just R. So L is just equal to R minus 4, right? Because we know that it stops at 4. We know that this point that intersects it as R. So this is just the length is equal to R minus 4, right? And L is kind of confusing because it should be length, even though we use R as right, and this is also L. So okay, so maybe we'll use delta, right? Let's just use delta. Sorry for the confusion. But yeah, the delta is R minus 4. And then what about the next one? Well, the next one is 5, right? So then this delta is also just R minus 5. And then dot, 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 all the way to 0, right? Well, you know, R minus R is 0, so we don't have to care. But the next one is going to be 1. The next one is 2, dot, 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 right? So that means that if you kind of bring this all together, you have 0, okay, fine. 0 plus 1 plus 2 plus 3 plus dot, dot, dot plus R minus 5 plus R minus 4. And where this 4 is just, if you do the first segment, and the first segment, let me draw a straight line. It's just the first segment in which the right side of the array is to the right of R, right? So that's basically the idea, and that's basically the solution. And we'll go over this in code. It's kind of tricky, I mean, you know, I didn't get it honestly, right? So I don't know. So for me, it's going to be tricky. But we'll go over the code. Yeah. So this part is the prefix sum. This is the binary search that we talked about, right? So here, at the end, right? Yeah. L is the last index that is K-Constraint good, right? Yeah. So then now, so that also means that right sub I, a string starting at I, ending at right sub I, all the substrings are good too, but we want to only count the starting at I part, right? Are good. So okay, and then this is just the length, right? So length of the string. Maybe I'll put it on top so that's a little bit less confusing. Right, and here, yeah, this is regular prefix sum. This is the binary search on the prefix sum. You can see that the prefix sum here is just that, yeah, either the number of zeros is less than K or equal to K, or number of ones is less than or equal to K, right? So okay, so we have either of these things, and then now we do a prefix sum on the total, right? So then now, L total is the prefix sum on length, right? So what does this do? This allows us to answer queries for the sum of the, oh, this is not, well, this is the length of the string, but the length of the string is that the length of the string or the count of the string? is the length of the string, which is also the number of good strings starting at I, right? And then now this enter the number of queries for the sum of the good strings starting a range query, right? Answer range queries starting from at from I plus 1 ... right? Range queries of starting at some index, right? And then now this is the thing is that yeah, and if you watch the really end of my video, there's a live solve portion of it. But yeah, but basically now for each query we do a binary search. What is this binary search, right? So at the end of this binary search, L should be the last element that's within should be the last element that is within bounds, right? What do I mean by that? What I mean by that is just that if you look back at the image, then this L is just going to be equal to this thing. So then L plus 1 is equal to 4 because that's the first index that's our bounds, right? And if you look at the code, this is what I wrote. L is the last element that's within bounds. L plus 1 goes out of bounds. And then here, we do a prefix sum, right? This is a sum on the prefix sum. This is a prefix sum on the sum, sorry. Which is from L to S, right? So here, we want to count, we want to sum up from S to L plus 1, or from L inclusive. So we do L plus 1 so that it doesn't count S, because prefix sum will always add by 1 to have the 0 if you have to, yeah. So yeah, so this is sum. Otherwise, so this else statement is basically, and this if statement is just that if the first element, if this is not true, that means that none of the elements are inside. So then now we want to update it so that L plus 1 is the first element that's our bounds, which is the first element in general. It's a little bit of a hack. You can actually change the binary search to also adjust this, but I think this is cleaner for me, so that's why. So yeah, but this is basically saying that even the smallest element is, yeah, and maybe you could have written this a little bit differently. For example, you could write it here, which is that if right of L is greater than Y, so if the first segment already outside of the range, right? Then we do this binary search with this thing. Otherwise, yeah. Otherwise, we know that it'll be inside, or something will be inside, and this should be good. I think this is good. I mean, let's actually kind of run it real quickly. Oops, nope, I messed it up. I mean, this is the start, right? With right of the start is greater than range, then we do a binary search. Otherwise, oh, well, L minus 1 is a little bit confusing. L should be just equal to S minus 1, I suppose. Well, this refactor has gone wrong. I messed up the order. If this is already out of bounds, then this is good. Sorry, it's very late. Okay. But this is why we always check things and we always TDD even minor code changes. Make sure that this is correct. Looks good, right? So okay, so basically this is saying that even if the first element is already outside of range, so this is maybe a little bit clearer, then we just set L is equal. So that, because then now we want to say that at the end of this statement, then now the invariant is that L plus 1 is out of bounds, right? If L plus 1 is the first element where the right bound where it extends our bound, right? And here you could see me do this for loop, right? It is just going to be, so the first item is going to be, so L plus 1, right? So then it's just Y, which is on the graph, and minus 1. So this is the number of things. And you kind of look at this, right? Then now you can see, I mean, I kind of did this on the live portion, but you can see that this is just if I is Y, right? If I is Y, then it is 1, right? So then now, so it's 1 plus 2 plus 3 plus ... plus if I is equal to L plus 1, so then it's just equal to E minus L plus 1 plus 1. And then this is, of course, the summation formula. And then you just sum to this. And that should be good. And that's basically the idea. And that's it. Yeah, that's pretty much it. Like I said, the portion that I was trying so hard during the contest was that I was trying to figure out, like I knew I wanted to sum all these things and then try to figure out how to subtract this out. And I just couldn't figure it out, like how to. I did it with some ideas, but it turns out that if you have to write visualization, eventually you'll get to it. But I was just, and there is an assumption about that, because in the sense that there is a thing that you have to visualize correctly, which I didn't, even if I had this visual, like I had this on a notebook, but I didn't visualize correctly, is because I didn't see this being 0, 1. Like I didn't see this being 0, 1, 2, ... because for me, if you didn't notice that the thing is that they're all offset by 1, and then you have the 0 plus 1 plus 2 plus 3 plus 4 ... thing. If you didn't notice that, this is still going to be O of Q if you kind of have to add them up in another way. Like you have to write this for loop. This is still like very slow, right? It may pass the examples or test cases. Oh, I didn't. If you have this for loop, it should still time out, right? Like if you had some maths, so you have to notice that it was going up that way, and I just never noticed it. But that's all I have for this one. Let's go over the complexity, right? The prefix sum, this is O of n, linear time, pretty straightforward. Or this is n log n. For each one, we binary search. You can upsolve this using sliding windows, as I said, but for now it's n log n. And this is O of n, of course, and O of n space. For each query, we also do a binary search on n, so it's going to be q log n. Q is the number of queries, and everything else is just O of 1. So in total, the way that I did it anyway right now is this time, and for space it's going to be n plus q. You can't really do better than n plus q space, because q is lower bound, and I guess you can maybe figure a way to do better, but then you sacrifice time. And again, if you do sliding windows, then you can reduce this to this. But I'll leave it for you to do at home, because this video is already going to be very long. But one more time, I'll show you my code real quick. Just a little bit smaller so you can see more of it. Here's the top with the prefix sum, binary search, prefix sum on the total, and then query handling with the binary search, which maybe I should have put in a function, and also the summation of all those things, which you can kind of see here. So it's just 1 plus 2 plus 3 plus ... plus e minus the smallest I, which is L plus 1 plus 1, which you could reduce. I know that you can reduce these, but I like to write them out this way so that it is clear what I was going for. And in theory, the compiler should take care of it. Do I know Python? I don't know. But anyway, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. And you can watch me solve it live during the contest now. I always forget this thing though. Alright. That was that took forever. Did people get Q4? Okay, people got Q4. 175 people got Q3, and I have 5 wrong answers, just as I predicted actually, so I guess that's kind of cool. People are very fast though. I mean, this is going to be a disaster anyway. Yeah. Okay. All right, let's look at this one. 69. People gotten it. Nice. 40 minutes. Let's focus. Whew, that was a tough one. I had to kind of take a mini mental break. But okay, so how do I do Q4? So one of the things has to be less than K. So we could pre-process with respect to K. Can we do something on string length? Maybe. That Q3 took too much out of me. Like that was tiring. Okay, I mean, it has to be something with prefix sum, I suppose. How do I do the math on prefix sum? At most K, what does that mean? Can I do something? Let's say K is 1. So then now the sub thing is just all going to be right. I guess that's fine. Or K is something big. What's my Q1 again? I guess I just did 4 loops and took a long time about it. Honestly, I feel a little too tired for this one, but all right, let's say we want to do the entire string. How do we get it? So on this, we could binary search to the left and then binary search to the right, or binary search to the left to get it for each thing, right? So that now we can say, okay, so that's the, so if we do it per character, we can do it for the entire thing. But then now, we cannot do, we can do some, can I sum it up in a smarter way? Okay, so then now each character contains the max to the left that it can go. Right? That's fine. We can binary search for that. That's going to be n log n with a prefix sum. Okay. Oh, to the right, it doesn't matter. And then now for a query, we want to sum over all that, but basically doing a chop operation on the thing. How do we do that? we want to do a chop operation on square root decomposition. 10 to the 5th is a little bit big for it though. What is square root of 10 to the 5th again? Like 225 or something? 316? Am I thinking of something else? No, whatever. So 316. Can I do a square root there? I don't even know if I could, but I'm just doing the math on whether that's even fast enough, and I don't think that is anyway. Let's say we pre-process it that way. Then how do we... Oh, we can just think of them as segments. And then we count the number of intersections of those segments. So we do a sum. No, but it's not even the count of the segments, it's the number of them. But we can do a second query to it, so I guess it's doable, maybe. Maybe. No, because then now you have other ones that comes before. So you have to figure those out too. Unless you take all of those. No, that doesn't make sense. Okay, can I go farther with this segment idea? Can I go for a segment? Yeah, I don't know if the segment idea works. This is gonna be terrible because I just have 5 wrong answers on this whole thing. But 100 people's gotten it though, and even more as we speak. People's got it in 10 minutes. I mean, they're smart people, but can I pre-process the queries? I guess that's the thing that I always forget. There are a lot of queries. Okay, let's say we want to pre-process the queries. That makes it slightly easier, maybe. This is the 2 and 3. Oh, the 2 and 3 is considered. So then now, because then we can update the answers to the no, but then they have the right side, and the right side is a little bit awkward for sure. Especially if you have like an infinite number of them, almost a big number, and you have to update each of these, and if you have to update each query, then it's only n times q. Like my case is if you have 0, 1, 0, 2, 0, 3, dot, 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 that would be, and k is something big, then you would have to update all of them. And don't we have an idea yet? How many people's gone Q3? A lot of people's gone Q3, and I have 5 wrong answers, so that's a not good. Any other things I can notice? Q2 should not have taken me that long. Okay. Yeah, well. With each number we can extend how far it goes. Right. Okay, let's say we have segments and then we just do all the queries together. And then we can do, okay, maybe we can do it that way. I just am a little bit dumb about it. Okay, fine. Let's go, let's say, I think this is a good idea actually. So maybe, I don't know if it's good enough, but it's a good place to start, right? So now we have no, well, I see, because then you sweep them all together and then you only care about them. Is that true? Is that right? These line segments, okay. So you have like multiple levels of line segments, okay. You want some of these. That's the thing, you only want a subset of, so you don't want it to go extend, right? Like I feel like I'm close, but I don't. It's just so tough. Okay, let's just go through it. Let's just do the part that I know first, right? Whatever, prefix 0, prefix 1. Yeah, new mistake of doing it with numbers. Okay. Right. Okay. And then now we have events that are from supply. So, okay. Now, just binary search, right? Okay, fine. Whatever, it doesn't really matter. So then now we want to binary search, okay? Yeah. Now we want to go to the right. We want to go something smaller. This is not L, it's I, which is actually confusing, but okay, fine. Okay, so this is good. So then we want to make the bigger array. So that means that we want left is equal to mid. Right. Maybe this is useful, I don't know. Okay. Why is that? No, this is inclusive bounds, Larry. Okay. So then now this goes only up to 4. Is that right for 2? Oh yeah, this is right because 6. Okay, and then everyone. Okay, so then now we have all these things. So 4 is going to last digit. So we can play around with whatever, but okay. So now you have all these segments: 0 to 4, 0 to 6, 0 to 6. All right. So this part was easy always, but then now, so 0 to 6 is just going to be you sum up all these. That's the thing, right? How do you even... Okay, so now you have n line segments, and each query we want to see what is the area under the line segment, almost. Is 0 to 4 the... 0 to 4 is only a 1 count anyway, but so we have to be careful about how to interpret this, but how do we do this without summing everything in a sloppy way? You know, let's say we have all these events, right? And 0 to 5 is everything, but 1 to 4. So now the 2 is from 0 to 2, so 1 to 4, so we only look at these things anyway. And then now you look at these things, 1 to 4, we get 9, because this is from 1 to 3. Is that right? That doesn't look right. Oh yeah, no, that's right. The code is better than I am. Okay, so 1, 2, 3. So then now you have 3 strings. Oh yeah, so number of strings. So I guess that's always going to be the... So that is the number of strings. Well, that minus the beginning. So 3 minus 0. The prefix is going to be 3. So that's going to be the answer. L minus plus 1. But then now, how do you get rid of the thing that goes beyond? Like we do 1 to 4, some of these goes to 5, but we only cut it off at 4, right? And sum it all up. I don't know how to do it. I feel like I'm close with the idea, but I'm just missing one thing to put it together. I mean, unless it is just like regular segment tree. I don't think so though, right? How does segment tree work again? That's the part that I've always had, but I just want to at least get something down, I suppose. Because you're not getting the max, you're trying to get the sum. But this is the sum with a cap. That is the parameter. We could have a lot of queries, and we're going to try to go left to right. Let's say we have 0 and then a 5. How does that? That means that it goes from 0 to 2. So okay, let's say we think of these as segments. Let me draw it out. Okay, so we have 0 to 2. We have 1 to 3. 2 to 4. 3 to 5. 4 to 5. And then just 5 to 5, I guess. And then now the 0 to 5 is just the sum of the entire box. Okay, I mean, I guess that's fine. 1 to 4 would be this, but then maybe I am dumb. Maybe that is the way to do it. Okay, fine. X is going to be x plus 1, right? And then we just sum it up. Right? I guess so. Am I just, maybe I was just being dumb then. Then queries. Okay, and then now we have this. Alright, so then now we have this. So then now we can just, I don't know, what is, maybe I am dumb. And I overthought it a little bit. 26, okay, so in 0 plus 5. What about 1 plus 4? 1, 2. 1 to 4 is going to be 1, 2, 3, 4. That's already 11, so that's not quite right. Right, so that's not, you can't just sum it up that way. And then 2 and 3 is 5, which I guess, no, this is wrong. And why is that wrong? Why is that wrong? Two, 3 should have 3. Am I just off by 1 indexing? That would be interesting. But these have 7 elements. Oh, well, I guess that's fine. Let's just write it. I don't even know anymore. So, it probably is wrong, but then that's fine. at least have something. I don't know that this is quite right, but right. Oh. Yeah, I mean, this is clearly wrong. That's what I thought, though. But I don't know. What am I? Why is this wrong per se? Because it counts stuff that starts before, right? So this 3 cannot be added because you have 2 starting from here. So then now we have to subtract stuff that started from before that. Okay, so then now 1. So that means that for 1 and 4, we have to subtract. Okay, yeah, I mean, this is the thing that I thought that I had running issue with. So for 1 to 4, you have to get rid of stuff that starts at 0. Maybe it's just maths in that way. It's just a sum and then, because then maybe it's just like math on double counting in all the regions. Okay, so we have this, it double counts this part. So we subtract the thing. Yeah, 462 is not so. It's pretty bad. I mean, I should have gone. I should have gone there with fewer wrong answers. I don't. You know. I think I'm just still missing an idea, honestly. I knew that this. I mean, this was basically what I had in my mind for the last 30 minutes, anyway. So okay, so this is the stuff. It just has one contribution, right? But it's one contribution starting from 0. I see. So let's say we subtract 0. Would that be good? Not in this case. It's not enough still. Because the contribution, well... One goes to 2. So what does that mean? So then now we subtract the 0 things. Okay, maybe I have to. Okay, 3 minutes. Focus. Okay. Okay. We have 3 minutes, see if we can get it. Okay, so see we have 3. But no, but that's not even right? I have 11. So if I subtract all the ones that starts at 0, then I would get 8. Oh, because we have to add back in the one that starts inside, which is starting at 3. Okay, so let's do that first anyway. plus, okay, so then it's this minus the sum of all this stuff, so minus of start or something like this, right? And this should give me 8 and 0, but then now we have to kind of do the ones that starts inside but doesn't leave outside, so we have to add in, but that's the part that I couldn't get anyway, right? That's the part that I always struggled with. Is that the one that intersects, and there could be a lot of intersections with the endpoint. Try to do it fast enough. Yeah, I can't get it fast enough, and definitely not like right now. Let's see if I can upsolve this, but I'm gonna give it like so the contest is about to end in like a minute in case you're watching. I'm gonna spend like an extra 5 to 10 minutes, maybe. But this was the problem that I had all along. Like, this was not new to me. I just don't know how to do it without, you know, in a fast way. Other than having, okay, I think I have an idea. I think that's what I was trying to do before, but the idea here is just having these events subscribe to these things. Because basically we have here, so then now when we sweep, we go, okay, so then maybe we have a lookup is equal to right? Or maybe just events. Events is equal to whatever. We listen to, right? And then now we want to listen to the right endpoint. So for SE and enumerate queries, and then define sub E dot append the endpoint, we append index. So we have to do that. And then now on the sweep, we know how many things matter. So then now for E in events sub I, then for index in the sub I, then we can have lookup of index. We want to subtract total sub I, something like this, and then we can do here to subtract lookups of index, because then that'll give us the prefix, right? Something like this. Lookup sub I, total sub I, key error 0. Key error 0. Which one? Key error 0. Oh, because I'm doing this. It should be collections account to say. I'm just, my brain is fried. 18. Okay, so lookup is gonna be negative. So okay, fine. Okay, maybe it's a little bit. Maybe it's before. Maybe it's just off by 1. I'm not sure, but I think this is roughly right. Maybe not. Where's my lookup thing? Let's print out the lookup for a second. Because basically this is saying that it may be off by 1 though. because this is off by, this is a thing, yeah. Still wrong. Because we subtract too much. So okay. This is negative, which is fine maybe. Okay, for example, here we have at okay, so then now we have these things, and then now we have a sweep, right? Is the sweep one? I'm a little bit just trying to see what works, which is not great, honestly. But okay, so lookup is fine. Index 0, 1, 2, so -3 on what I had. Right? Why? Because 5. It should be here. Maybe this? I don't know. We want to listen to it after it ends, and it's inclusive, so I think this is right, but I think this is a little bit wrong. I don't need to subtract anyway, so let's just do it this way. It's a little bit more what I am thinking of. So at 0, this is 6. That's wrong. I think this is now I, not I plus 1, but so 0 is 0 because that's 5. At 4, there's 3 things starting out. Is that right? Is this right? The 4 is 3. Let me see, I actually drew this. At the 4, wait. I want to print total, that's what I wanted to do. Okay, so then now, oh, no, that's right. Right, so then now it has 0 to 1, okay. Is it inclusive? Yes. Okay. So that means that at 2, okay. So okay, yeah, so it leaves at that one. That's fine. Maybe I'm off by 1. But there's 3. So there's 3 things inside. Is that true? I guess so, because it just goes to the end. Okay, so 1 goes to 2. 2 goes to 3. 3 goes to 4, right? So why is this 3? What does this 3 mean? Oh, 3 is just the number of segments inside, which is probably true, because then now, because our right should be whatever. Yeah, so I don't know where this 3 comes from. What's this total? 0, 1, 2, 3, 4. So then this 4. So you have 3 segments leaving it, but oh, we have to do the start part as well. I see. Because basically we and this is not just the number of segments, it's the sum of the things after the segment, right? So that's the part that's a little bit tricky as well. So I don't think this is right anyway. As is. because total is just the number of segments, not everything after those, what these segments do. Which is the issue that I had in to begin with. Okay, yeah. This isn't quite right then. Yeah, can I adjust this to be whatever? Okay, so let's say we have these events that we want to listen to. And now we have this sweep, right? And we don't know how, without keeping track of the index, which we really don't want to do, because that'll make it n squared. Or n times q or whatever. Yeah, I don't know. Yeah, I guess I'm missing something in trying, or the way that I'm trying to do it is a little bit too clever. The contest is over now. I'm trying to think what was 600, yikes. But I mean, Q3 should have been doable. It is still tricky, but probably not a 5 long answer tricky. I just didn't think through all the cases. I was rushing a little bit. For sure. Q4, I don't want to click on it yet. I'm still thinking about it. Maybe this is a little bit too crazy. Because basically, we don't want to just count this. I mean, we undercount or we overcount anyway, but which is actually kind of. I mean, okay, we overcount probably just because I'm off by 1 somewhere. I think it's fine. But I think this is kind of. Did I change something? Why is this? Wait, why is this negative? Huh? Why is this negative? Why is this negative? It should be 0, nothing. This should be 0. No, I guess it's before we add this. Okay, fine. But then now we move to, no, I mean, I don't know how we got -3 on this one actually. I guess we removed some stuff from the beginning and then some stuff from the end. Yeah, I guess we moved too many things. I don't know how to do this one. Let me see how long I can think about this. Oh, excuse me. Yeah, I told you to will end up getting it. Yeah, and I also miss the case. I mean, there is a thing where like the ranges also goes from left to right. So there's so many cases with this. I don't know how to handle it. Quite all of them. I feel like I'm missing like one hint or something. Like we could also think about the queries, but and then for each one we can think. But that's the thing is that I don't know how to do it in such a way that is not n times q. Because for each query, if we look at each cell, even as the events, I mean, I guess that's what I end up doing anyway, except for not completely. But and also the way that I did it is a little bit awkward anyway. Because if I did this sweep line, I didn't even need to do this kind of thing. I thought I could use this to get rid of some stuff, but if I'm going to do it this way, then it is also just the sum of all these, and like, I don't know, some part of this is just the sum of all this stuff, right? So it doesn't even make sense. And then we have to subtract out the extra stuff. Subtracting out the extra stuff is how I'm not I don't know how to do. Because basically you're just cutting it off, kind of. Yeah, I think I did more work than I actually was initially thinking anyway. But because all I need is the L total, right? We don't need, the way that I do it now, I don't need a lot of these things to be, because it would have been just incorrect anyway. So then now it's just the sum of, it's just the prefix sum, but then you have to, this is going to be, just for clear, I know that this is wrong, but it's like, something like that is basically the first iteration that I had, and I still went into the same issue. Yeah, I went into the same issue that I had with not able to chop things off. I know that there is an idea about querying offline, but I just don't know how to use it. Like if for each I we have to look at a lot of queries or even just some queries, then that's already not good enough, right? Like we use this to I mean, it just becomes an MSQ. Like the start is fine, but then the ending. And the other thing that we were doing was trying to get all the segments. But the segments is not enough. Though yeah, I don't know. I feel like I'm missing a piece. Like I've been basically on the same idea since 20 minutes into this problem, and right now I'm already. Oh well, I don't have a counter on it because that is on the entire contest. Do I give in? This is such a poor rank. Yeah, I don't know that I have a better. I mean, maybe it's just something that like as soon as I see it. All right, let's cheat for a second. Let's see if I could. I mean, this is the idea that I have. Well, a lot of this looks like the thing that I look at, so I don't know. M is equal to query. Kind of terrible naming, but okay, fine. I mean, that's fine. Okay, he did it with sliding window, I suppose, but yeah, I mean, this is basically what I have. I did it with binary search, but it's the same, I suppose. And then, yeah, I mean, it's fine. And then now, count sub I. Maybe I just don't know how to do math. So this is the length, and this is the prefix sum of the length. So I already have this, right? I pretty much have this is what I call L total. Right, so I do have this. So there is another binary search on the thing. I guess I didn't have this part. I just saw binary search, but LR is equal to, I mean, if low with mid, do we sort the input? No. Okay, so basically, this function is monotonically increasing, which makes sense because everything to the right. So then now, everything to the right of that is going to, I guess it's just formula is what he's saying. Everything to the right of that is going to be, okay, let's try it. I mean, I guess I just suck at math because I think I had this idea, but I just couldn't work out the math. I mean, I don't remember the formula really, so, okay. So maybe I have to try to figure out how to prove the math part about this. So left is equal to the S. Yeah. Right is equal to okay, so these are the ones where I'm still struggling with this, even if with this cheat hint thing, right? But this isn't good. So we're trying to get the first segment that has a thing, which makes sense, but I just don't know how to do the math from it. But maybe I'll figure it out. I was very close though, maybe. I mean, everything else I've set up for a while. So okay, so if good of mid, and what is good of mid? If mid is if right of mid is then y. So within those starting things, we try to find the first thing that is in bounds, I guess. So okay, so if and this is terrible naming. Okay, fine. Let's just use LNO again. Maybe I just for this one, I guess I just didn't know the math, honestly, or the formula. What? I mean, this part I can do. Oh man, terrible namings. Okay, so that means that if the middle is within it, then we want it to be big. I think I like it the other way, where if this is greater, if the mid is greater, then we want the right to equal mid minus 1. All right, so then now L should be the last element with should be, or L should be the last element that is within bounds. L plus 1 goes out of bounds. Okay, I mean, this part I okay, fine. But I still don't know how to do the chopping, and I think that's where I just missed the math, which is this part, I suppose. So this part I literally have somewhere here, and then it's this, which is that if this is, so okay, so then now if L is greater than less than E by the lingual, then how does this work? I think this is the formula that I don't know how to do. All right, we could work. Let's see if this works, and then yeah, and then we'll have to dissect it. I mean, I think this is L choose 2 or something, or like that number choose 2, but I don't know. I mean, this isn't quite right. Unless I'm like off by 1 in some case, which is possibly true. And this goes out of bounds for some reason. I guess this is the way that he wrote this. If L plus 1 is the one that goes out of bounds. Yeah. Okay, so that looks better. But then now, because this is L plus 1, maybe this... I don't know if this is right, but... yeah, I don't know. I mean, everything else should be basically what he wrote. I mean, there is a geometric, like it's L minus R choose, or plus 1 choose 2. Maybe, well, it's the summation of all those things, I suppose. But I don't know how to get a... maybe my thing is wrong. Alright, instead of just trying to... I'm trying to reverse engineering this problem. I mean, I think most of my ideas are there. I just don't clearly... clearly I'm missing... missing the insight for this particular piece. It's either that or I'm just really wrong, and yeah, because basically, because in a funny way, like I did basically everything that he did. So I have this array, which is the same as this array, right? So yeah, look, so I did that, and then now. This part I also did, so maybe we could just print answer, and here we could print result. And then I'd remove these. Okay, let's remove these. No, this should be. I just didn't want it. Maybe. Okay, so the result is a little bit off, which is actually surprising. Their count. Oh, what is? Oh, huh. Okay, this is actually wrong or different. This is their L, so actually this is after the binary. Okay, that makes sense. Actually, I just didn't really think about it. Apparently. But yeah, okay. So then now this matches except for this 3. Oh, should be the last time. That makes sense. I think this should be good. Why? Sometimes you have to, you know, grind it out. But I am still trying to understand this in general. Okay, so my L is different. And maybe because my loop is different. Is what I say wrong? L should be the last element that's within bounds. Oh, I see. Because I think I choose L as S, so I always have one item. So I guess that's why he has like this thing about this, which is actually a little bit awkward, but I guess it makes sense from that thing. Because then now we're able to go out of bounds. I mean, okay, fine. I mean, maybe I have to do something just like if right of L is less than or equal to E, then we do this, something like that. And then now this should be no. I mean, our L's are different, but that's fine in this particular case because this basically just checks the thing that he does with doing this -1. But but then now we have this formula, which maybe now that I did the other part right, maybe this is just right. Nope. I was also don't do E plus 1, so maybe that gives it an issue. Also, in their case, their L plus 1 is different than their R, so R is actually L plus 1 already. So, which is also kind of awkward, honestly, but okay, fine. Maybe it's this way. Nope. If L is the last element within bounds, I agree with that. If L plus 1 I don't know, but I don't know the explanation for this anyway, which makes it a little bit hard to debug because yeah, even though everything else is roughly the same, I still like my binary search this way. Maybe this is a little bit awkward though, but I'm just double checking. I think this should be right, except for the different definition. This is R, or there are. Maybe there's some like weirdness. I don't know, but I still don't understand this formula to come up with it, because you have to figure out how far it extends, right? Oh, I see it. Okay, I see. I am dumb. I am dumb. I see it. I don't need their code anymore. Okay, I see it. Okay. Then now, it's that I changed it to this part that I realized, and then now, L plus 1 goes out of bounds. So from L plus 1 to E, we have. Oh, I just didn't. This was the insight that bugged me the entire contest. That is, I was thinking about chopping things off the entire time. I didn't think about adding things on. Such an obvious insight, but okay. So we extend to E, right? So then now it means that we want to say, let's write a for loop just so that I am just yeah. just so that I can so y minus I plus 1, right? Maybe I just want to get it correct. I don't know why this is still a little bit low though. Maybe my binary search is off because it starts at 2. So is 2 the, am I right or am I wrong on this one, on my binary search? So we have L, right? We have L is 2, so 0, 1, 2, right? And it goes to 3, so we have 2 plus 1, but L is 2, so 0, 1, 2, that should, yeah, we should go from 2 to 3, right? So, okay, print summing. Oh man, I'm missing this insight. Now I feel a little bit bad. Okay, summing. Okay, so I'm just really bad at this then. Okay, so y minus I plus 1. Oh, this should be L. Fix this, but this is wrong. Why? And even this one actually. L should be L plus 1. L plus 1 is the first one that goes out of bounds. Yes. And then this goes to L plus 1. But then now this doesn't work for some reason. From 3 to 3. Is that true? I thought L is 2. Oh, L plus 1 is 3. Okay, so here L should be the last one that's within bounds. This is why we add this. So then now, okay, 2 is the last one that is within bounds. I think that is correct, because then 3 extends to 4. So then now we should add 1, which is correct. But this part is not correct, I suppose. Right sub L is I was having it off by once, but okay, fine. So 2, 3. Right sub L is 4. Really? Did I do this wrong? No, this is the last one that is inclusive. So okay, so 2, 3. Right? Yeah. L is 2. E is 3. Okay. So, but right sub L is 4. Why? I'm just having off by ones, but I know how to do it now. I'm so dumb. I feel so dumb. Why is this 4? So 0 goes to 2 and 2. Okay, because the way that we store right. I thought I did it the right way. Where L is the last digit. Did I do this wrong? Did I do my binary search wrong? If both of these are right, then minus. No, this should be right unless I did this part wrong, which is also possible, honestly, at this point. Yeah. Maybe. Right sub I is. Well, it's a little bit wrong because this should not be n minus 1 if, you know, so this should be inclusive. So right sub I is for 0 should be not be 2, it should be 1. So that means that my binary search is a little bit wrong, right? It's k is equal to 1. So that means that, is m plus 1 right? No, 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 no. You have to be consistent. I did m plus 1 because I did from m to I. So if m is equal to I, then it's I minus 1. No, this should be right. Did I have some weird thing? Why? I guess I'm just having two weird issues. Okay. Yikes. But I should have gotten this one, this contest. But I don't. Yeah. It's fine. Focus. I just missed one visualization. Okay, but I could still finish it, Larry. So finish it. Defend your honor. Why is this the? We started I. Right. So that means that m, if m is I, then we have one element which is true. So why is this wrong? I think this should be n. Yeah, but that's what I saw earlier. Prefix should have n plus 1 elements though. I don't know why something is a little bit awkward. Okay, so if they're both, I could only be n minus 1, so this will become n 2 times n minus 1. If you do it by 2, it's going to be n minus 1. So m should be n minus 1 plus 1. So this should be at most n, right? So what is this giving me? Why is, I mean, I changed it to this because I thought that I wanted this, but then I changed it to this for this reason. But then I don't know why I'm going out of bounds. I is equal to n. This is right. This is right. Right. So, oh, this is wrong. That's right. No. This is right. Yep. It's not so bad. 788. Yeah, I mean that's what I thought. But then I'm getting complaints about this. Let's print it out. Which part of this is it the I? M plus 1? Oh, well, m plus 1 is 8, so 8 is not going to be good. But how did I get 7? 6 and 7 is going to give 7. Okay. I do have 6, 7. Okay, 6, 7, 7, 8. Is this m plus 1 or m? No, it should be m plus 1. No, the default should be 0 characters. Okay, fine. Okay, fine. So then now, is to write what I expect. Right is is 3, 0, 1, 2, 3. So this is just wrong. Okay, that's what I feared. Oh no, this is right. This should be n plus 1. Or yeah, if this is exclusive bound, it should be a little bit better. This is neither. I think this is more right, but then now okay, focus. What does this mean? What is m? M is the inclusive bound. If it's inclusive, then it should be m. No, you want to include it. So I don't know why this is wrong. You want to go for, so you have bounds of 6 and 7. So it's 8 minus whatever. Don't I have 8 things? How do I even get to 7? Oh, because of this n thing. Man, I suck at binary search today. Okay, but this is still wrong because this is now exclusive. 3 is I mean it's exclusive except for these parts, which is now inclusive. So that's where I'm having issues, is that my binary search is just very awkward. Because it's not consistent. Okay, 0, 1, 2, 3, 4. So okay, so that's good, but that's inclusive. Well, this is inclusive, but then this is exclusive from 0 to 2. Why? K is 1 on this one. Oh, no, you're an idiot, Larry. Okay, no, this is good, Everything's inclusive, it's just 0, 1. This is a valid string, I just confused. Yeah, because there's only 1, 1, so this satisfies, so this is good. Okay, so all this time I'm just being silly. Alright. Debugging the wrong things. Okay, so like, I'm usually pretty good at binary search, at least on this stuff like this. That's why I was so confused. But okay, so that's right. Okay, so then now let's check our homework again. So then now we have from 3 to 4. For which one? I already kind of lost all my... I'm confused these days. Okay, LE is 2 to... Oh. It's not LE, but okay, fine. SE and then L. Put it that way. So don't we print this? Okay, I guess so. Okay, so from 1 to 4, so this is the input. We have 2, because... Okay, let's just print out right, just in case our binary search is not correct. Okay, so we have this thing. We want to see the first instance. So L should be the first instance that's, or the last elements that within bounds. So that means that from... I spent like an hour on this. Today's just not my day, I suppose, but that's fine. Okay, so then L is L is 2, so that means that this is 4, and this is the last element that's within 4, which is correct. So then now what? 1 to 4 is going to be 9. I guess this is the right one, so I don't have to look at this one actually. 2, 3, 2. Okay, so then that means that the L is 2. That's not correct. Oh, is my binary search dumb? No, it's just that it's just that the first one goes beyond that, so this should have, yeah, this doesn't do anything, which is what we should expect, because yeah, right, yeah, so this is what we expect, but the 1 is not what we expect. So we start from 3 to 3. Oh, because the L is 2, but it doesn't count the fact that L can be smaller than the starting. So we count L plus 1 for some reason. Because L, this is not technically true, because L doesn't have to be in bounds. So if L is not in bounds, then we just L subtract by 1 to make it out bounds. Then we get the entire thing, and then there we go. Okay. I am yeah, it's a little bit awkward, but let's get it correct, and then we'll clean it up afterwards. So then now you have this, right? This looks good. I'm gonna submit it. I know that this is wrong because it should time out, but I just want to get a timeout, because if I get a wrong answer before the timeout, then we can fix it. Actually, that's actually hilarious. But oops, how long does it take anyway? 2 seconds. So we didn't even have to fix that, but we should anyway. But that's kind of okay. That makes me even feel a little bit worse. But yeah. So this is just Yeah, there are two ways to do it, I suppose. So this is just sum from 1 to e plus 1, right? So sum from 1 to e plus, or 1 to e, sum from 1 to e, which is going to be, I always forget this. So 1 is going to be 1, 2 is going to be 3, so it's 2 plus 1 over 2. Okay, so e plus, or e times, yeah, e times e plus 1 over 2. And then, so subtract by, now we want to subtract out everything less than L. So it's just L times L plus 1 over 2, right? So something like this. Yeah, the comments a little bit confusing. Let's just see if it's right first. Okay, that's wrong. Why is that wrong? Well, so we want to go to L. So we subtract everything from L. Right? So 1 to L. Oh, no, the inside formula is this, it's not, okay, so then now it's e minus I. Okay, so I messed up on this formula. What am I doing? Okay, so then now now we have e minus L plus 1 plus dot 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 plus when e is equal, when I is equal to e, this is going to be 1. So it's 1 plus dot 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 plus all the way to this number, right? So then now it should be basically what the other dude did, which is e minus L plus 1 times this plus 1 over 2. I know I wrote it in an intentionally confusing way, but it, so it's this number plus, right? Why do I, so the result is e, it is going to be 1. If the result is L plus, oh, this is inside, so okay. I think this should be this, which is why there's a confusion. Okay, fine. So then here, and then here. You used to mess up when you do it too quickly, and also I had to comment this out. You used to mess up when you do it too quickly. Let's give it a submit. Okay. Yeah, overall not a bad problem, yeah. Yeah, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this problem, my explanation, this video, everything in between. Stay good, stay healthy, take good mental health. Have a great rest of the week, everybody. I'll see y'all later. Take care. Bye-bye.